Again, I'd also like to say, along with everyone else, that your talks today have been brilliant. Unfortunately, I could only turn up for this afternoon's talks, so I missed the morning ones, but the ones I saw this afternoon were amazing, much like Becky and Peter and a lot of other people in the room. I've been to a lot of national and international conferences throughout my research, and yours are way more exciting. So, I'll try and use this next one. So I wanted to come today to talk about my journey from A-levels through to becoming a researcher in the field of nuclear fusion, because I don't feel like my path was a particularly obvious one to me, and maybe it will resonate with some of you in the crowd today. So when choosing my A-levels, I found it a really difficult decision to make, primarily because I knew that this decision was going to really shape my future career, but I had no idea what career I actually wanted to have. And the only real experience I had of careers, okay, this is a slightly old version of these slides, so the animations are a bit strange, but you have to bear with me. So the only real experience I had with my with potential careers I could have were my family had their own interior decorating business, and some of my close relatives were hairdressers, scaffolders, teachers, chefs, and none of these jobs I could really see myself doing or see myself enjoying doing. And the only way that I could see myself getting a job that I actually enjoyed doing was to start my own business and shape what career I would have. So when deciding my A-levels, I decided that business studies and maths were going to be really important if I wanted to start my own business, and I also did further maths at A-level as well. But I still needed to pick another A-level. And throughout my education, I knew that STEM subjects were, of course, very important. And maths I was already doing. Engineering and technology I didn't really have a lot of experience with. And so science was left. And my confidence in science was really rather low. And in the end, I decided to go for physics. And hopefully, yeah, sorry, the animations are a bit strange, but we'll get there. So I went for physics because physics was the most maths-like subject. And I really enjoyed doing the business studies and the maths, but my confidence in physics really stayed quite low. And throughout the beginning of my A-levels, I started joining young enterprise groups to help build up my business experience. And then during the first year of A-levels, we had the opportunity to go to CERN, which I know that some of you have done in this room. So before going to CERN, the main reason that I really struggled with physics was because I didn't understand why we were learning everything we were learning. Why did we have to learn hundreds of equations and theories and bits of information, all stuff that people already knew, just to pass an exam? I didn't understand what the point of all of that was. And then we went to CERN, and I saw men and women doing real science experiments, learning new stuff about the world around us. And I genuinely had no idea that any of this was going on, which might seem a bit strange to some of you in this room because you're already brilliant scientists and you know about CERN and all sort of different experiments going on, but I genuinely had no idea that science was still a real thing that was happening. I thought it had all already been done. And the work they were doing at CERN was just inspirational. And I also learned that scientists have a sense of humour. So, animation's a bit strange. When we were walking around CERN, this was obviously back in 2007. Yeah. And so the Higgs hadn't been discovered yet, and there were various kind of whiteboards around as we were walking around, sort of different departments kind of poking fun at each other and making jokes. Of course, there is Higgs. And the trip was brilliant. It really opened my eyes to this world of scientific research that I did not know existed. And when we returned from our trip to CERN, I started to really enjoy my physics lessons again. So I started to understand kind of why all of this was important. I had a bit of context as to why we were learning these things. And when we did come back, We had the opportunity to go to London to the Big Bang breakfast, which was amazing. So we got to see CERN turned on for the first time live in London, listen to loads of talks from researchers about the work that they were doing. We were invited to the BBC to watch Becky on the news, to go to radio stations and talk about our experience. And what was really exciting for me was that we showed up in Astronomy Now magazine, and I was quoted in the magazine talking about my experience about the day. And all of this just really reinforced for me just how exciting science is and how everyone cares about science, and there's this massive community of scientists. So I started to get more of an excitement and an enjoyment for physics and for science research. And I then, around this time, Lucid was just starting up at the Langton. So yeah, you all know more about Lucid now than I do. It's changed somewhat. But Lucid is the Langton Ultimate Cosmic Ray Intensity Detector, as you know. This was remarkable. I couldn't believe that this was happening in school. Before this came along, all of our science experiments were rolling cars down a hill to measure acceleration, sending lasers through prisms. All these experiments, somebody already knew the answer, and it was just kind of going through the motions. But this was something new. This was a school project where the experiment was going to go onto the International Space Station to collect new data that people had never seen before, and students were doing it, and I couldn't get my head around it. I was still pretty lacking in confidence in science at the time, and so for me, I was just in awe of the students that were running this project. I took a bit of a back seat with the project and just kind of absorbed what was going on, and talked to the students about what they were doing, and just found so much inspiration from the work that they were doing with Lucid. And hopefully Peter doesn't mind for putting this up, but I was astonished that someone my age managed to get a scientific research paper out of the work that they did with this. I think it's incredible. I don't even have a scientific research paper yet, hopefully within the next few months. But it's amazing. This is a school project doing this. I just thought it was incredible. So I then came to the end of my A-levels and had to think about what was going to come next. And I was still on this track of thinking that I wanted to start my own business. My confidence in science was still kind of low, even though I was massively enthusiastic about what was going on. I'm going to start my own business, so I was going to go to university to do economics. And I must have looked around at least 10 different universities at different economics courses, and with each one I went to, I became more and more uninspired by what I was hearing. For me, the economics courses I was looking at were just a repeat of what I'd done during my business studies courses. They weren't going to challenge me, they weren't something new, something exciting. It was just something to get towards making my business, and it wasn't going to be an exciting journey. So I didn't know what to do, and my parents suggested that I might as well look at a couple of physics courses, and I did this and decided in the end that I would, even though I didn't think I'd be particularly good at doing physics at university, it would be something that would excite me, it would challenge me, and that I'd enjoy doing it. So I gave it a go. I started a 4-year Masters in Physics at the University of Surrey, and this course is a 4-year course where I get to do a year of research. And I spent my research year in Canada, in Vancouver, and I got to work with machines, doing all kinds of different physics experiments, hands-on experiments, and my parents and my family got to come out and see me as well. And for me, the most exciting part of this is that I started then to realise that I can do physics. So this was the first time that I was doing real science experiments myself, leading these experiments, doing things, collecting data that nobody had seen before, and I was being successful. We were getting good results, we were writing papers, and this was incredibly exciting to me. But what was even more exciting was that I also got experience into why this research is so important. So all of the research at this lab, the Triumph Laboratory, is all kind of nuclear physics research. So they're creating nuclei and then finding applications for them. And they have a proton therapy facility at Triumph, which is this rather terrifying looking picture at the top. That's not me. So this is the proton therapy facility, and people with cancers of the eye, melanomas in the eye, can go to this facility, which is at the lab, and the same protons that are accelerated for use in our research are also directed to this therapy centre, where they're directed into the eyes of the patients to cure the cancers and fully restore their eyesight. So alongside this sort of groundbreaking research that the lab's doing, they're also helping the community. Also from the lab, there are underground tunnels that go to the local hospital, and at the lab they create medical isotopes which are sent to the hospital and used for various different types of treatment. And this was brilliant. This was research. They're constantly finding new isotopes that are going to have amazing applications, and at the same time creating those isotopes that are being used every day to help cure people and fix real-world problems. And so I now started to get a real passion for physics and for physics research. And out of all of the different courses that I did during my undergraduate course, there was one that really stood out to me, which actually really surprised me, and it was nuclear physics. So nuclear physics was the one subject out of all of these that really stood out to me, mainly because of work that I did at Triumph. And I will just give you a very brief introduction to the field of nuclear physics, and to do this I'll start with the periodic table. So the periodic table, as you all know, shows us all of the elements that we currently know to exist. And actually in this periodic table there were a few elements missing that we actually discovered within the last sort of 5 years or so. So these are all the elements that we know to exist, but in nuclear physics we take those elements and we replot them onto two axes, the number of protons versus the number of neutrons. Now, as you know, all of the elements, so atoms have electrons orbiting a nucleus of protons and neutrons. And so all of these elements will have different numbers of protons and neutrons inside their nucleus. And so we can actually replot the periodic table onto these two axes using those numbers of protons and neutrons in the nucleus. So this is the periodic table in nuclear physics. Now what we can do with all of those atoms is that we can add and remove neutrons from the nucleus to make isotopes of those elements. And the brilliant thing in nuclear physics is that so far we've created and studied around 3,000 different isotopes, and there are currently, using our various models, there are still 3,000 isotopes that we haven't created yet that we predict to exist. So there's still so much more to do, but the exciting thing is that all of these isotopes, we're not just creating them, studying their properties, but we're finding applications for them. And there are loads of different applications for all of the isotopes among the periodic table. I've just kind of gone through a few quickly here. Everything from kind of carbon dating through to various medical applications. And of course, even in our smoke detectors, they benefit from the discovery of 241 americium emitting the alpha particles. So I became really passionate about the applications of physics research, kind of not just doing work but doing work because it could change the world. And I recently finished my PhD in nuclear physics, and just a few weeks ago, so I'm now a doctor at last. And I then had to think about what I was going to do afterwards. So my career, I currently work at the Culham Centre for Fusion Energy, which is just down the road from here. And I work with currently the world's largest tokamak device, known as JET. And JET stands for the Joint European Torus. So at JET, pretty much every day, we create a plasma inside, and that plasma can reach temperatures 10 times hotter than the centre of the sun. And at these temperatures, we're then able to fuse together deuterium and tritium, which are heavy forms of hydrogen, to release massive amounts of energy. Now, if we can collect that energy we can then use it to power the national grid in a much more environmentally friendly, clean and safe way. And what we're currently working towards in devices like JET but bigger is that we're creating materials inside that will actually breed fuel for the device. So the device will be self-sustaining. As it's creating the energy, it's creating its own fuel, and it can just keep going forever, hopefully. So just to give you an idea of kind of how amazing these machines are, if we were to run a device like JET for 1 second, we would generate enough power to continually boil a kettle to make 60 cups of tea. And that would use 8 micrograms of fuel, which is the same as about 1/10 of an eyelash. To get equivalent energies in the burning of coal, for example, you're looking at burning more like a few 100 grams of coal, which is sort of 1 million times, at least 1 million times heavier than the amount of fuel you're burning for fusion. And of course, some of the many obvious benefits is that in fusion, the only waste product we're producing is helium, whereas in the burning of coal, we're obviously releasing all kinds of toxins into the environment that are leading to kind of climate change and all sorts. So fusion is really the holy grail within energy to achieve this goal of powering the national grid through fusion. It's a massive energy source. And it's a very interesting and exciting field to work in. If any of you are interested, then feel free to ask at the end if you want to come on a tour of JET, which I do quite a lot. So this is kind of what I'm doing now, and this has been my journey from A-levels all the way through to becoming a fusion researcher, which was certainly not the plan, but is certainly a much better plan than the one I had. So CERN at school was what I was kind of introduced to during my A-levels when it was all kind of starting up, and it really introduced me to this exciting and inviting world of science. And I'm really glad that in the end I had the confidence to go to university, not to do what was easy, but to do what was challenging and in the end a lot more worthwhile and exciting for me. And it opened a lot of doors into this world. So studying science at university was really important for me, and I'm very grateful to now have a really exciting career in science that I just love sharing with people. I'm very proud about the work that I do at Culham. And I think I'd just like to end by saying that CERN at school I think is an amazing opportunity. For me, I wasn't particularly confident. CERN at school kind of helps sort of invite me into this world. And I think although not everyone in this room will become a fusion researcher at the Culham Centre for Fusion Energy, it will hopefully inspire you to have the confidence to go out and to do what you find interesting rather than what you feel you should do or what you feel comfortable doing. It will hopefully encourage you to do something challenging and to lead you into a career that you're passionate about. So thank you very much for listening.